Assalamu alaikum, my dear students. We will continue our chapter Powers and Radicals Part 2. Objectives: define the notion of the cubic root. Define the notion of the nth root of a real number where n is a natural number and n is greater than or equal to 2. State and apply the properties of the nth root of real numbers. Please prepare the following materials: textbook, pens, draft papers, copybook, and calculator. It is required to have a previous knowledge about the following topics: to write decimals using powers of 10, to use the remarkable identities. Cubic root. Definition: a and b are two non-zero real numbers. We say that b is the cubic root of a if and only if b to the power 3 is equal to a. Property: a and b are two non-zero real numbers. b is the cubic root of a. It is denoted by this notation, and we read it: b is equal to cubic root of a. Example: 2 to the power 3 is equal to 8. Then 2 is the cubic root of 8. And we write it: cubic root of 8 is equal to 2. Cubic root of minus 64 is equal to minus 4, since minus 4 to the power 3 is equal to minus 64. Then minus 4 is the cubic root of minus 64. Remark: cubic root of a to the power 3 is equal to a. Example: cubic root of 27, it is equal to cubic root of 3 to the power 3, which is equal to 3. Cubic root of minus 8, it is equal to cubic root of minus 2 to the power 3, which is equal to minus 2, according to the above remark. Application: complete. Pause the video and solve the application, then check your answers. Solution: nth root of a real number. Definition: a and b are two non-zero real numbers, and n is an integer greater than or equal to 2. The nth root of a is every real number b, such that b to the power n is equal to a. The nth root of a real number may or may not exist. Property: a and b are two non-zero real numbers, and n is an integer greater than or equal to 2. If n is even, then any positive real number a has two opposite nth roots, b and minus b. The positive nth root plus b is denoted by nth root of a, where n is called the index and a is the radicand. The negative nth root minus b is denoted by minus nth root of a. Example: 2 to the power 6 is equal to 64 and minus 2 to the power 6 is equal to 64. Then 64 has two opposite sixth roots, where 2 it is equal to sixth root of 64, since 2 is positive. If n is odd, then any real number a has only one nth root b, and it is denoted by nth root of a. Example: 2 to the power 5 is equal to 32. Then 32 has one fifth root, where 2 it is equal to the fifth root of 32. Minus 2 to the power 7, it is equal to minus 128. Then minus 128 has one seventh root. Then minus 2, it is equal to the seventh root of minus 128. Existence: a and b are two non-zero real numbers, such that b is the nth root of a, and n is an integer greater than or equal to 2. If n is even, then if a is positive, nth root of a can be calculated, and we have nth root of a to the power n is equal to a. If a is negative, then nth root of a does not exist, and we have nth root of a to the power n is equal to minus a. Example: Sixth root of 7 to the power 6, it is equal to 7, according to this rule. Eighth root of minus 11 to the power 8, it is equal to minus 11, which is equal to 11, according to this rule. Fourth root of minus 16 does not exist, since minus 16 is negative, according to this rule. Remark: square root of a is equivalent to radical a. So from now on, when we see a radical without an index, this means that the index is 2. If n is odd, then if a is positive or if a is negative, in both cases, we have nth root of a can be calculated. And we have nth root of a to the power n is equal to a in both cases. Example, cubic root of 2 to the power 3 is equal to 2, where 2 is positive. And fifth root of minus 32, it is equal to fifth root of minus 2 to the power 5, it is equal to minus 2, where minus 2 is negative. Application. Now stop the video and solve the following application, then check your answers. Solution. Property. If n is even, then nth root of a minus b to the power n, it is equal to a minus b if a minus b is greater than or equal to 0. And nth root of a minus b to the power n, it is equal minus a minus b if a minus b is negative. Example, n is even. Sixth root of radical 2 minus 1 to the power 6, it is equal to radical 2 minus 1, since radical 2 minus 1 is positive. Fourth root of 1 minus radical 2 to the power 4, it is equal minus 1 minus radical 2, since 1 minus radical 2 is negative. Now if n is odd, then nth root of a minus b to the power n, it is equal to a minus b if a minus b is greater than or equal to 0, or if a minus b is less than 0. Example, n is odd. Fifth root of radical 2 minus 1 to the power 5, it is equal radical 2 minus 1. And cubic root of 1 minus radical 2 to the power 3, it is equal 1 minus radical 2. Application. Simplify. Pause the video and solve the following application. Solution. Notice here that 9 minus 3 pi is negative and 2 is even. Then we write it minus 9 minus 3 pi. And minus pi minus 6 is negative, but since 3 is odd, so we leave it minus pi minus 6. And 15 minus 5 pi is negative, and 20 is even, so we write it minus 15 minus 5 pi, and we continue. As for the second part, we have x is negative and 4 is even, so we write it minus x, and here we have x is negative and 7 is odd, so we leave it x, and 64x to the power 6, we write it first 2x to the power 6. If x is negative, then 2x is negative, but since 6 is even, so we write it minus 2x, and we continue. Property. Let a and b be two non-zero real numbers. N and p are two natural numbers greater than or equal to 2. Now consider the following properties. We have to consider two cases, if n is even or if n is odd. If n is even, a and b must be positive. If n is odd, a and b are non-zero real numbers. So a and b can be negative in this case. Now, the first one, nth root of a times nth root of b, it is equal to nth root of a times b. Same for n is odd. nth root of a plus or minus b, it is not equal nth root of a plus or minus nth root of b. Same here. Nth root of a over nth root of b, it is equal to nth root of a over b. Also here the same. Nth root of a, all of it to the power p, it is equal to nth root of a to the power p. Nth root of pth root of a, it is equal to n times pth root of a. Example, cubic root of 2 times the cubic root of 32. We can write it a cubic root of 2 times 32, which is 64. Then it is equal to cubic root of 4 to the power 3, which is equal to 4. Cubic root of 24, it is equal to cubic root of 2 to the power 3 times 3. So we can separate the cubic root to cubic root of 2 to the power 3 times the cubic root of 3, which is equal to 2 cubic root of 3. Fourth root of 32 over fourth root of 2, it is equal to fourth root of 32 over 2, which is equal to fourth root of 16. It is equal to fourth root of 2 to the power 4, which is equal to 2. Cubic root of 2, all of it to the power 2, we can write it a cubic root of 2 square, which is equal to cubic root of 4. Seventh root of a cubic root of 11, we can multiply 7 times 3, so it is equal to 21st root of 11. Application, simplify. Pause the video and solve the following application, then check your answers. Solution. Another application, simplify a and write the answer in the form of a cubic root of 2, where a is an integer to be determined. Pause the video and solve the following application. Solution. Since the final answer should be written as a cubic root of 2, this means that each radicand should be written as a number multiplied by 2. Minus 16, we can write it minus 8 times 2. 54, we can write it 27 times 2. And 128, we can write it 64 times 2. And we continue. So we get the final answer is 8 cubic root of 2. It is in the form of a cubic root of 2, where a is equal to 8. And finally, solve please the following application, simplify. Stop the video and solve it. Solution. Assignment. Summary. Coming next, we will see in the next video the following objectives. Thank you for watching.